Welcome to the second review of MATLAB. In this review we will be just comprehensive like for all what we covered in MATLAB, including the new material like loops and if condition and like user-defined functions. So let's start. So here this is like random number generator plotting and figure formatting. So plot the figure that looks like this. You need to plot a figure that looks like this. First, plot the function. So like you plot this function for 100 equally spaced value of x in the interval from 0 to 2. So you have like from 0 to 2, you just plot this guy. Use solid black line, then draw a random samples of 10 value of x and display the respective, like, so basically draw 10 random sample from 0 to 2 and calculate the f of x, like y as a function of x, and then plot them here. So they will not necessarily be at the same location because these are just like, so here like the 10 random sample one was at this x is equal to, I don't know, point like 3, 0.31, like 0.7, like 0.9, you know, so, but you will not necessarily have the same thing, okay? So here, like, yeah, note like you read like this random sample, like these 10 random sample, like they will be at different location. Okay, so let's just do it. So let's find our x first. Our x is like line space. What do we do this? From 0 to 2, and I want to have like 100 points, okay? So I got like my x, my y, that is equal to sine, and that is like x dot, like, don't forget to make this like, because we want to do this like element by element. So basically what we are doing here, let me show you what's happening here. So if I run this, then I have, this is my x, okay? Then I want to, my y is x cubed, so each of these elements, I raise it to the power cube minus 2. So that would be like my y, okay? And then let's just plot this. So if I plotted this, and my y, again, if I, let me show you if I did this, okay, if I did this, and I have like that is like my y here. So here is like a vector of 100 element, and this is like another vector of 100 element, and then I just like plot this guy like x and y. Then I got something that looks like this, not exactly. Why? Because this is let me hide these guys. Let me hide these guys and plot this again. So what is missing here? So a few things are missing. Labels are missing. So I have like x and y labels. The grid is missing. The title is missing. This is a blue line. This is a black line. So here you come here, like you make this K. See, put like this thing. Now I have this as a black line, and then it's easy. I can just say my X label. And for these things, you get like easy grade because you just write X, like my Y label. You will get here, that would be Y is equal to sine x cube. That will not give you the superscript. Like if you don't remember how to do the superscript, you can go to like the plotting lecture note and see this. So to do like the superscript, I think what you need to do, I don't even like remember, but it could be maybe something like this. If you put it like between the curly brackets, that should give you the superscript. So let's do this. Yes, that did it. Like I need to close this bracket. So you don't necessarily like need to remember these things. So like you have a cheat sheet that you can check it in, or like you check it in like online, you Google it or whatever. So now we have something that looks like this. I'm still missing a title here, random sample of size 10. So like title would be like random samples with size 10. I need to have grid, so like this is like grid on, maybe box also box on. So now I have a grid, so I'm almost there. I'm almost there. One thing is still missing is like I need to add like these random like these markers here at like a random location. So like how to add like these markers, basically I want to take like 10 samples, so I can say like my markers, that would be like, remember like rand, like if I said like rand, for example 10 1, that will give me like these like 10 random sample of x. But like I want these to be not space between like 0 and 1, I want this to be space between 0 and 2, so I multiply by 2. Then I got like some random samples from like 0 to 2. And then I have like my m here, or like let's say like my m here, like my marker, my y marker. I need to now estimate like my y value here, so my y marker, so that would be like this guy like time m here. Then I should get like also like my, see this is my marker at like this x location, and that's the corresponding like y location. And then I just like plot, so I plot my m and my y m, and like that needs to be a marker, like you see that needs to be like, so here you come here, you put like this O, like again if you don't remember this, like you can check it. Let me show you where to checking, like you go to plotting, you can go here for example. It's like still slow to have this, my computer has a slow processor. Okay, but anyway, you will like it will need some time to load. I don't know, like okay, here we go. So like remember, like if you want to like simple marker, like if you want a circle, you use this O, and like for R you use red, and you can check like these details here if you don't remember. So here then I put like this red, okay, and then will this plot? No, because remember I need to hold on, because I need to hold on to this guy and then add this one to it. So if I did this, now I have like something that looks like this. Maybe I can make, set the marker size to 4, so like this marker size is like big, so like I said, like you come here like marker, and select marker size, and then like put it equal to 4. See, like now it's adding to the previous figure, like I added this, it keeps adding to the previous figure. How could I just create like a new figure and not keep adding to the previous figures? And remember, like you close all. So here, like this is all things that you need to remember. So like you close all, and then now I have like something that looks like this. It's like my 10 marker. So I got like the, let me hide these guys here, hide this guy here. So I got like a figure that looks like this. Again, like this marker location does not need to be the same as the same location, but it is here. Okay, now I have another plotting problem. Now it's telling you write a code to plot this figure. Like you have a figure that looks like this. The number of sample is like 10,000. The black box, bottom left corner, so this corner here is x equal to 3. and y is equal to 1, and the upper left corner, like this corner here, x is equal to 8 and y is equal to 4. I mean, this is a puzzle. I mean, this is couldn't be like straightforward, but let's just think about it like basically you need to like just like how to plot. These are just random numbers. Like if you plotted like a uniform distribution, like you think this is like a uniform distribution from like 10 to like just a uniform distribution, like from 0 to 10, and you just like plot it, you do this for the x-axis, you do this for the y-axis, and then you will be able to get like a plot that looks like this. Let me just show you how to do it like with 10,000 samples. Like generate samples from like, let's say like I will just generate like I will say like s samples. That would be equal to random, and let's call it x, for example. Like let's generate the x samples. So the x sample, that would be random. So my number of samples is like ns and 1. So now I will have an array like and then I need to multiply this, remember, by 10, because this will generate just random number from 0 to 1. If I multiply it by 10, then I got it like in that range. Then I do this here, my y is equal to this guy, and if I run this, let me show you what will I get here. Or I mean, I can even display it here, that's okay. So if I run this, then I get an array of like 10,000 samples from that ranges from like 0 to 1, and same for y. And then I can plot them, like I can like say like plot x and y, and then I would like to just use like dot, like just use a dot, because I don't want to plot this as line, I just want to plot them as dots. So if I plotted this, then I got the dots that look something like this, okay? So basically, for like each value, so basically I will take like the value of x.2 here, and then like corresponding first y would be like 0.9 here. So I plot this point, and then this point, and this point, and this point, and keep all these points until like I get a figure that looks like this. But actually this is a puzzle. This is not an easy problem. This is kind of a tricky problem, because I'm telling you this should be black, and like everything, and this should be green. So basically how could I so basically this means that my 10,000 samples, which I have here, that I just plotted, I need to index them in a way that if their values lie somewhere here, that should be like one set, while if their value is like in the green area, that should be like another set. So here, find indices of sample within the black box, okay? And then plot the black box, and then do the same for the so now let's cancel this thing, and like we just want to find the indices that are in the black box. So how can we find these indices? Remember, so we can say the indices of the sample in the black box, we can say ix, for example. So ix, that would be x, okay? Remember, this is like from x equal to 3, x like larger than 3, and x smaller than 8, okay? X smaller than 8, something like that. So now I found like the indices that are like larger than 3 and like smaller than 8. And then I could find like the y indices also, like indices in the y direction. So that would be like y larger than 1 and y, remember, less than 4, okay? Less than 4. So now I found here, these are like the indices that are like in this region, and the x indices in that region, and then I can just like basically I can just do this plotting. So here I can just say like plot x, and then I just take like the I of x and this will not work. Why? Because this will not be equal. So if I want to make these equal, I basically need to find like this indices. So that will not work, because like if I did this and this will not be equal. So I basically want to find like something like this. I want to like this guy should be here, and this guy should be here. Basically like these two conditions, like so, and I can just call this index, not necessarily like index. So now here I found like the indices of where the x value is between like this guy, and then like the corresponding y value is between like this range. Okay, then I index x, I just do index x here, and then I do like y, index the y here, okay, and then I put like plot, and I make this green, for example, and then like, oh, this is the black, sorry, this is black, remember black is k, and then I find here x that are not these indices, so that would be like all the other element, and that will be green. So if I did this, I got like the shape that I have, and why I didn't get this the black one, because I forgot to put like hold on. So you can easily like, you know, get like these things. Okay, now I have it. So now I have like the shape that I need. Again, this is like not an easy problem, it requires thinking, but if you can do a problem like this means that you have like a good understanding of like indexing, and I mean you are like at a very good level in MATLAB programming, because that is you can like do indexing, like you can find the index of like these terms, you can do like index with them and do the ones that are not these indexes. So that would be like a good problem, I would say, to try to understand it, and if you understand it, this is like you're a good like MATLAB programmer. It's like a good level. Okay, let's move to the next one. Like, so this one is easy. Like I'm saying, you use the array A to reproduce this figure with vectorization without using loop. For repmat, repeat the array like 100 times. So let me just show you how this array look like. So if we just like plotted like this guy, so that's array A, that's like from 50 minus 1 to minus 50, and then if we plotted it, oh, it's still like MATLAB is slow, still like working on something. So you see here when you run and it's doing this means that like the script is running. Click go to evaluate line. Okay, so now we will just wait. I just want to show you like how this line looks like, and then we will see how we can do like repeat matrix, and yeah, MATLAB is very slow. Or my computer, or both of them, you know, together. Okay, so now, so you see this line looks something like this. So here is the yellow, this is the blue. So now I need like another one of it here, like I want to like have a mirror image of it here, and then I want to repeat it like 100 times. So how can I have a mirror image of A? So basically I can say A is equal to I flip A, no, the A is equal to like A, so I wanted to have it first and then have like a mirror image of it as well, like flip A left to right. like flip it left to right A. Then if I did this, I plotted, then I got like, let me clear all these outputs here. Okay, so if I, like now I have A and the mirror image of A. So where is this A going? Oh, okay, I have to hide this guy. So I got something that looks like this. Yeah, I mean, maybe it's okay to see. So A here, that's like a row array of 101 element. Here I took A and then I took a mirror image of it, but flipped left to right and A, then I have this. Then I want to create an image like this. This is by repmat. So A equal to repmat. So I want to repeat A. How many times do I want to repeat it in the row direction? 100 times. How many times do I want to repeat it in the column direction? 1 time. Let me hide all these guys so that we just get like the image. So here I repeated it like 100 times 2, and then if I plotted it, then I got this image. If I just put 100, like I didn't put, that will like create an array that's like 100 by 100. So that would be like a huge array. I mean, I don't know how it will look like. Probably it will give an error. Yes, so it's like plotted something like this. That's not clear. Okay, so you need to specify something like this, and I got this one. Okay, now let's do this problem like reshape, repmat, and some function. Water pumped from 3 well are water pumped from 3 well are, so this is pump, like how much water you pumped from 3 wells in meter cube, such that each well has 4 records. So basically that would be like well number 1, that would be like, that would be like well number 2, and that would be like number 3. Okay, the energy required per meter for the 3 well are, so basically these are well at different depths. So here, like this would be like the deepest one because it requires more energy. This would be the shallowest one because it requires like less energy. Use reshape, remat, and some function to multiply. So I want to multiply like this one by this one and find the total energy per well. For example, pumping well, the total energy would be like for pumping well, like you have these 4 elements, and this is how much energy you need per meter cube. So that would be like 10 times 24, 23 times 24, 12 times 24, and 30 times 24. So let's just look at this here. So here we have our this one. Now we want to reshape this to get like the 3 wells. So basically we can say B is equal to like reshape, we want to reshape B. We want to reshape it to have like 4 rows and like 3 columns. So 1 column for each well. So now this is how much water I pumped from the first well, from the second well, from the third well. I have like the energy, so that's like the energy per well here, something like this. So now that is like I want to multiply like this guy by like these guys, this guy by this guy, this guy by this guy. So how can I do this? I mean, you can use a loop, which is not a good idea, or you can just like repeat this one. So like you can say like QE, that would be like I repeat UE, I repeat it, like I repeat this guy, and then how many times do I want to repeat this guy? Like 4 times in the row direction, and how many times in the column direction? Just 1 time. So I repeat this guy. Now I have like, now I can multiply like all this guy by this guy, like element wise, like multiply 10 times 24, 23 times 24, and then multiply it element wise, and then I can do my summation. So I can say here like the energy, or total energy, that is like B time UE. So then, and don't forget to put like this dot, because you don't want to do matrix multiplication, you want to do element by element. So basically 10 times 24, you got this. And then I want to find the energy for each well, like, so let's call this maybe energy, and then like total energy, that would be like the, for like pumping well one, that would be the sum of these guys, the sum of this guy, and the sum of this guy. So here, that would be like sum of energy, and in which direction do I want to, like, should I put 1 or 2 here? Like 1, I sum in this direction, 2, I sum in this direction. So I just want to put in direction 1. So if I did this, then I have like my, for each pumping well, like pumping wells, that's like 100, 800, and 1100, something like this, okay? Now this is like a loop problem. So I tried to find like a problem that you will do by loop, not by vectorization. I mean, we can still do it by vectorization, but we didn't cover like mesh grid in the class. But it would be like, if you don't know like mesh grid, it's be easier to do it. Because remember, I told you like vectorization or array operations, there are so many of them. We didn't cover everything in class. Like we didn't cover mesh grid, for example. We didn't cover unique. We didn't cover, there are so many like of these array operations. The more you learn MATLAB or like this type of like interpretive programming language, the more you will learn about like these other array operations. So mesh grids, that's also in Python. You will also find it in Python, not only in MATLAB. But anyway, let's just do this with loop. Like, use a loop to create an array A with size 6, 5. So I mean, we can just initialize this array A. So we can say array A is equal to nan, okay, 6, 5. You can initialize this array. So basically, if I run this, then I got like 6 times 5 nan. Okay, with the value of each element is 2 times its row number minus 3 times its column number. So basically, like, you know, this one will be like, let's do like, for example, the value of A 4, 5. So A is just like number 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Like the value of this guy, that would be like 2 times 4 minus 3 times 5. So that's like 2 times this row number minus 3 times its column number. Do not display A in every iteration, so suppress your answer. Suppress output to screen for all lines and display the final value of A. So how to do this? That's like very simple. So basically you can loop first for all like columns and then loop for all rows. So for n, like for n equal to 1 to 5, for example, and then for m is equal to 1 to 6. And then you can say like A, remember here this is like row, and then this is the column, okay? That would be equal to, again, like the value of each element is 2 times its row number. So here its row number is like 2 times m, so that's its row number, and minus 3 times its column number. So that would be 3 times n, that's like the column number, okay? So it's like 2 times m, row number, minus 3 times n, and, okay, and, okay, here. So we, if we run, and again, like suppress all this because we don't want to keep showing this like, I don't know, 30 times. So like if you put A here, we can also suppress our initial guy here. So you got something that looks like this, okay? So basically the value of each is like 2 times its row number, so that's like 2 times m, and minus 3 times its column number. So you got something that looks like this. Can we do this with vectorization? Yes. So basically, like you can do like mesh grid. So mesh grid, basically that will create like a matrix N and a matrix M that has all the pairs of N and M, like, and then you will, once you have like these matrices, then you can, oh here, I should put like minus, not plus. That's a mistake. So here is a minus. So if I run this, then I just get the exact same solution. Let me show you what's n and m in case you are wondering. Oh, my MATLAB is again not cooperating with me. MATLAB is unhappy. Maybe the memory is full or something. Let's see. Clear. Okay, now clear. Okay. Oh, MATLAB is not cooperating with me, but anyway, you can just do this on your own. Just check what's n and m, like to see like what is the output of this, and then so that's like the loop solution. That's the vectorization solution. Again, you are not expected to do this in the exam. If you got a problem like this, and oops, something is happening here. Now MATLAB has started to respond. Like minimize this guy, okay, and like put like my workspace here. So I have my workspace here. Let me show you what's n and m. That's a good thing to see. So that's like my m here. That would be basically something like this. All these guys, okay. And my n here, that would be something like this. So basically, m, that will create like, so remember like, and here from 1 to 6. So I have like from 1 to 6 here, and it repeated it. So basically, this is like a repmat here, and then here from like 1 to 5, and it repeated. This is like a repmat here. So that's like mesh grid. So basically, so you get like all the combination, like you got like 1, 1, 2, 1, so on and so forth. So that's like called mesh grid. It's like so you can also, but we didn't do this in this class because so you don't. I mean, this is something you shouldn't know. Okay, I just want to show you like if you want to do this with vectorization, how can you do it? Okay. Now, like the last problem for this review is that we will like write a user-defined function that calculate something that looks like this for a vector t of 100 evenly spaced point between t is equal to 2 to t is equal to 5. So let's write the user-defined function. So like, do you remember how to do this? So basically, like you will have a function. That will be your function. You will pass to this function basically like k and b, and then it will give you back like u and r, and then you can plot like u and r and t. Okay, so basically that's like the input that you will pass to this function, and this is the output that you will get from this function. So do you remember how to do this? Like you go here, you will live a script, you do like live function, okay, and then like we can come here, not like this one, we can come here, we can like just like, let's just copy everything like Control C, or you can just like do copy here, and then like you can come here, you can paste it so that so basically I should also like rename this function. Let me call it like, so I have a function here, I will maybe call it like FUR function. So I call this like FUR. Let me call it just FUR1, okay, because I might have this already on my computer when I save it. So FUR function, that will take k. Remember, that's the input. That will take k. It will take b. That's like the input of this function, and it will output two things. It will just output f actually. It will be just like the. It will output like this f here, because remember I want to plot f versus t, and then like this function itself, what is it? F is equal to, what should I do here? that would be like minus 0.5 time log, and remember like here should be log 10, don't make this mistake again, log 10 over like u. Okay, and I will, so now I need like to have a u here, so let me make a u, so u is equal to k, which is like a number over, and like you remember like the precedence rule, so 2 times t, you need to have a bracket here. So now this is my u, so I take like log 10 of u, okay, plus my okay, f, my r, okay, which is what do I have r, okay, so now I need also to have r, so r is equal to k over b, okay, so that is like r, my r time u to the power 4 divided by, I need to open like bracket 4 time, and you know, remember like this guys, that's like factorial function, like factorial of like 4, okay, sure. So factorial of 4, and then I put something that looks like this just to suppress this one. So I'll put here from this function, and if you want to make it, okay, that's okay. You can do it something like this. So basically, like this function, we can save it now. So I can save this is like fur1, okay, this is fur1 function. So fur1 function, it will take k and it will take b to calculate like u and r, then it will like calculate f based on like this urr value, so 0.5 minus log this one r u to the power of 4 times 4 factorial, so you got something that looks like this. So now I have my function. I can copy it here, and then like I can come here, and then I can just like do it. Okay, now something is missing here. I pass to it k, I pass to it b, and also pass to it like t, because it also needs remember here, like if you look here, and then I pass the t, because it also needs time somewhere here, or it doesn't. Oh yeah, see, it needs time here, so it needs k, needs time, and it needs b, so I pass also the time to it. So these are my 3 things that I will be passing to it, to this function, and then I will be plotting t versus f. Okay, so let's now time, like, so the t is equal to line space, so I put like the line space here. What should I put in this line space? I should put so the time evenly spaced like from 2 to 4, and I need like 100 point. Okay, so let me show you like how this will look like. So if basically I can make it even a column vector. So I got like from 2 all like the way to 4, like 100ly spaced like point. This is like what I got here. Now I need to put my k is equal to 10. I need to put like my b is equal to 1.7, and like my time is equal to like this guy. I can suppress all of them. I pass it to this function. I got my f, like very, see, like the good thing about function is like your code is very clean, only 3 lines, like all the calculation, all this equation and blah blah blah, they are just here. Like you got like a clean code here, and then you just plot your t versus f, and let's plot this, yes, and it gives me like, okay, so now I have like some error here. Why? Because this is like a vector, like u here, because t is a vector, so u is a vector, so I should like put like a dot here. What other mistake do I have here? Like R is R a vector? No, R is just a scalar, so that is okay. I don't need like a dot here. You can put it, doesn't hurt, but like I need like a dot here because that's like a vector here divided by this one. So now I have something like this. Now I corrected my function. I come here. F I got like an infinity, so I still like have an error in my function. Why do I have an error here? Like this is log u maybe. This is k2 times t, so that's correct. K over b, that's correct. And then I have like 5 minus log, again this is log u, so like let's see like the, you know, if you want to debug this you can just do it line by line. Like if you put like something, oops, oh, it's not like working, or you can just like let's just see what's my UR. I run this. Why U is not like, okay. Yeah, my MATLAB is slowing me. So I have like this infinity value. I think that's why I'm getting like this error. So let me, MATLAB is slow. Probably there is like a mistake. Yeah, MATLAB is not really responding. Here, come here. It's not responding. Wait. Yeah. Just wait until it responds back. Okay, here we go. So that's like our function here. Now let's do debugging. So when you do debugging, like if you click here, and then like you run this guy, like if you run this guy, okay, then you see it stops here, and then like you can see what's happening here one by one. So like you can see your U, for example, like if you go to the workspace, you can see like your U values. So your U values here, they are all like 0. Why they are all like 0? You see this is are all 0 except only for the last one. Why? Because K, I mean that shouldn't be the case, because basically like K here, just like a scalar, you are dividing it by 2 times T. Let's check our T. So like we can come here, we can check our T value. So T is something that looks like this. So basically when you multiply, like basically K divided by K, which is here like 10, divided by 2 times T. So here like that should be like 2.5, but like I don't know why here you are not getting something like this. I'm getting a 0. So that is, I think that's the problem here. So I can stop here and then go back here and check my case. That's how you debug a code. So I think that's like a good debugging exercise. So these are my t here. K is equal to 10. So I'm passing like this function. Let's just do it one by one. Like you can come here again. Like, okay, now you step like my k, like you see like my k here is equal to 10, b is equal to this guy, t is equal to this guy, then you can step in. Like now I'm entering through this function. I come here, I have like my k here, that should be equal to like, let me see the value of my k here. Like if I come here, k is equal to 10, so that's correct. Like my time here, that's like the time that I'm expecting, which is correct. So hide this guy, then like go back to like the step in. So if I stepped in, so now I have like my u values. Let's check the values of u here. So again, like I'm getting these u values of 0. So probably there is something here like k. Let's just do this like, I don't know, like let's just get the command line here. It's a good debugging exercise. So the command line here, I just like k. So k is equal to 10. Like 2 times t, that is equal to something like this. Then if I said like k divided by this, so you see here it's working, but here it is like not working here. So I don't know why this is not working here. Like see in the command like line here, and like I'm doing it, this is working. This is strange. I mean, I never expected to have an error like this that I don't understand. Maybe like we put like a dot, but like it doesn't matter because k here is k is 10. This is like divided by 2 times t. Okay, I think maybe, I guess I know why. Could be like I need to save this one. Could be like, let me save this function. Maybe when I save this function, I didn't save it with this input t. So let me run it again with this like input t. Like now I have this one, I'm inputting t. So here I have my function. This is like fur1. Let me do it again. So let me run this. Oh, I'm still like getting this error here that f is equal to be basically equal to infinity all the way except the last one, because I have this u here is somehow not working, which I don't know why. So maybe why this is not working, I really don't know why this is not working. But like we can, let's try to do it again. Let's do it one by one. Like so we come here, okay, we run this, we like step inside this function. Now we are here, we are trying to, let's just evaluate, let's just write this down here like copy, okay, and just evaluate this in the command window. Like so if I run this, okay, see I'm getting like all these zeros except like this one here. Why? Like how about k divided by 2? Let's see what will I get. Like if I k divided by 2, then I got 5. Like k divided by t, what am I getting here? I'm getting all these 0. I think that has to do with my t. So my t here, but my t here is okay. So that's really strange. So like let's do like, see, that's how to debug a code. Like I don't know why am I getting this weird error, because this really shouldn't be. Let's do, okay. So here, that is working now. Like when I do put this like dot division, that's working. So like this is maybe, let's do it something like this. Okay. If I dot this, okay, now it's working. So it required like that, you know, when I divide by k, I do this dot division, which shouldn't really be the case, because like this dot division is, you know, like this is a scalar, k is just one value, t is a vector, yeah, so you can do this without like this dot scalar, but somehow here it's not working, like it needs this like dot product. I mean, that's kind of, I've never seen anything like this before, but at least now we know the error, where the error is. So that's like how to debug your code to find an error. So basically you come here, you put like this dot division, that should be okay here, and then like maybe, I mean, let's put it also here so that, you know, we don't get like more of these types of errors. But anyway, you do something like this, you come here, and let's see if it will plot. So now, okay, now I got my f, now I got like my plot, so I get like this fading function just as I expected. So like F, like here, you get like with time, you get more like drawdown or whatever like this function is. Okay. So that was this. It was a good debugging exercise, an unexpected debugging exercise, but at least you learned additionally how to debug your code, like to be able to pinpoint out like where the error is. I think that's like a good exercise that just came by chance. And I think that's all for this review. And I think that's like would be like the last lecture in this MATLAB course. Okay, thank you for watching all these recording, and if you have question, just feel free to ask me. Okay, bye bye.